I want to talk about RSTP, stands for Rapid Spanning Tree Protocol. It is actually open standard, and it's defined in IEEE 802.1W. Of course, the traditional STP is 802.1D. So, today, you are most likely to see Cisco's implementation, which is RSTP plus. So they just use RSTP as the underlying mechanism for their Cisco proprietary prevalent spanning tree protocol. So that you can actually have one instance of a spanning tree per VLAN and use rapid spanning tree. So yeah, and there are terms that we should be familiar with before we dive into the configuration. So we have port roles. So just like the traditional STP, we have root port, designated port, and blocking port, or the port that is neither root port or non-designated port. But here, with RSTP, we have root port, which is the port that is closest to the root bridge in terms of cost, and every non-root bridge has at least one root port, and number two is designated port. This is there should be on every segment or link there should be at least a designated port. This is you can choose. This is chosen by looking at the lowest cost to the root bridge lowest cost to the root bridge. And number three is alternate port. This is the port that is less desirable, or the port that is alternate port, as the name suggests. Alternate port to the root port. So to the root bridge. Sorry. So if you have one switch with two uplinks, one of your root ports should be the root port, and the other one is the alternate port. And number four is backup port. This is usually seen on if you have two redundant links going to a shared media. For example, if you have a switch if you have a switch and you have two links connected to a hub, and so you have redundant links. So one of those links is designated port, and one is backup port. So let's talk about port states. Port states is, let me just look here. So number one is discarding. This state just combines the 802.1D disabled blocking and listening states. But here in RSTP, you don't need learning state because RSTP can quickly negotiate state change without listening for BPDUs. So if the port is in discarding state, it's not. It's just blocking BPDUs. It's not receiving BPDUs. Actually, heard someone said that it's still receiving BPDUs, but I'm actually looking at the book that I'm reading now that it's not listening for BPDUs. So learning state is not needed because RSTP quickly can negotiate a state change without listening for BPDUs. And learning state is just like the learning state in 802.1d. So it is populating the MAC table, the MAC address table, and listening and receiving and sending BPDUs, but not forwarding data frames yet. But with forwarding state, it is receiving and sending BPDUs, populating the MAC table, and receiving and sending BPDUs data frames. I actually need to be 100% sure about if discarding, because it's combination of disabled and blocking and listening state in 802.1d, so it should not be receiving BPDUs, right? But I need to verify that. And the last thing that we are going to talk about is link types. So number one is point-to-point port. It is if you have two switch and their ports on both ends are in full duplex, both switches assume that the link is point-to-point. And number two is shared point. If you have a port on the switch that is in half duplex and is connected to a shared media, like for example, if it is connected to a hub, it is automatically a shared point. And number three is edge port. This is the port that is connected to a end host or to a host. So it is you can define it by using the command span and treat port fast, just like in 802.1d or the traditional STP. So yeah, that's it for now. I'm gonna talk about other things about RSTP in the next video. So that's it for now. Thanks for watching.